All right.
Hey, I can hear you.
Hey. God, the state of things. I mean, crumbs. Anyway, so the first of all, the sort of fundamental things about LLMs that we're picking up on that we want to capture. Um,
Mhm.
Code is bad. We all know that. Code is cost. Code is suffering. Code is fault. And the problem is you kind of need code to get something done, but in general, you want as little code as you can possibly get away with. Um, if you were to pay developers by the line for code, the person you should pay the most is the guy that reports a negative line count on every payday.
Yeah.
That's the guy. You need that guy. Right. So given that we can observe an LLM to do the equivalent computation of what a very large code base would be, and
Hmm.
given the number of memes around the size of node modules rivaling the mass of the universe,
Yeah.
it would seem that it is possible to do all the computation you ever need inside an LLM where the programming, in inverted commas, of the system is a collection of natural language processes that the LLM follows using a very small number of tools like a for loop, a while loop, a web call, very basic language native features. And the LLM is the thing that is the execution context. It's the node modules folder. It's the dependency graph. It's everything. And it's simply acting like a Turing machine, except instead of the cursor, it's a little human that gets moved around the tape, picks up data, follows the instructions in written format, writes them down, all that, right? So,
Hmm.
so that seems to be I don't know what to call that kind of realization, but it basically says that the apps of the future should consist of like, I don't know, 100 gig worth of inference parameters plus like 200 kilobytes of text. and, you know, and to illustrate where that came from, if you recall the sufferings we endured for even just imagining how the Tendermint algorithm would have worked for consensus between nodes and all these kinds of things. What does the network graph look like? How do I know if I'm overloaded? When should I form a new connection? Seemingly on and on and on. If you can do all that by LLM, where the
Hmm.
LLM is the one, for example, that's executing the steps in the Tendermint algorithm between other peers who are also running an LLM, and so your message passing is it's not schemified, it's just what the LLMs accept as correct format, which can be just natural language. Um, at that point, you can make a blockchain with very little software.
Right.
So that's sort of point number one. I'll keep poking at that one. Uh,
Okay.
Point number two is that since the dawn of Interbit, the question repeatedly was raised, how do we handle large state?
Right.
And as far as we got with it was that when, first of all, when is a state large and when is it not? That's up to the developer to decide. The point of child chains was to allow you a way to have state that was nested in a structured way,
Right.
but then comes issues with how do I do delta compression when I have a state that's mechanically large but the developer considered it small enough? Do I
Delta compression meaning
do I
like
just take diff of what the previous state
different patch.
was?
Yeah. Okay.
Do
Yeah.
I write the whole thing down again, even if it's like a gigabyte? Do I introduce a custom format for JSON where I turn the JSON into a trie so that it's
Hmm.
efficient to look up? If I need to recover an arbitrary path in the state, how do I know which previous blocks I need to retrieve to get that path? All these are questions that are the same as Git.
Yep.
Yeah.
Yep.
And I don't know, you can correct me if I'm wrong, but I never once heard any of us come up with the idea of why don't we just use Git. I never heard that idea. And yet, we
Yeah.
use
No.
it every day. Every day.
It. As a you're not wrong. You're not wrong, right?
Yeah.
I mean, I think like all the like special data structures, all the consensus, all the voting mechanisms, all that stuff is stuff you could. In fact, I mean, if you kind of zoom out far enough and look at what GitHub is basically a voting mechanism for when like action when like branching
When's a
actions
merge?
happens on a chain, right?
Yep. When's a merge?
so so it's literally GitHub and the political dimension that I guess that it adds to code, like you could view that as like a blockchain consensus.
You could. More importantly, the underlying structure. So, um, managing the network is, if you'll excuse my French, a motherfucker.
Yep.
Yeah. And coding for that is even worse than being a problem. Like, how do you code for a problem that's even hard to think about and talk about? Like that's, it's not fun. But I am confident that a natural language system can be constructed where if you proposed a series of, just call them natural language statuses, where you said, okay, here's a list of nodes, this is the bandwidth, this is my total capacity. Hey, GPT-4, what's the next move? Here's the rules of the game, and here's the current state of the board. What do you do
Hmm.
next, right? I
Yeah.
reckon that with a bit of tweaking and tuning, where the tweaking and tuning involves natural language, you could get a pretty good outcome from that system. And you could argue that you could code a system that was more efficient, more quicker, more whatever. Do you need to adjust the state of your peer-to-peer mesh network more than once every 10 seconds? I don't think so.
Well, I mean, what kind of environment would you be operating in where that would be true? There's no like where like contention forms on a sub 10-second interval. Like I don't know. I think that sounds.
Just give me a second, buddy. I gotta put on some headphones just so I don't be an annoying co-worker.
Yeah.
Can you hear me?
Yeah. Can you hear me?
Okay. God, I'm tempted to try streaming again. Anyway,
Mhm.
so the Git process, the way that they handle large state is they don't do it for binary files. They only do it for text, and they use diff3. I think the algorithm is called. But the point is that for a sanely structured JSON object, the diffing works really well.
Yeah.
And what's more, it's generally available to any text document. It doesn't have to be constrained to JSON in any way.
Mhm.
So there's that. Um,
Can I tell you what else I don't, or
yeah,
what else I do like about the idea of just using Git?
yeah,
It
what's that?
it's not bound up in compute timing and network and all this. It's like the gossiping of it, the replication, all that stuff is kind of out of band, right? Like
Out of band. That's right.
it
That's right.
it's
That's right.
so all Git does is model time, basically, right? It models change in time, and like
Mm,
it doesn't really
better.
give a shit about
It
where
models
you.
it models data over time.
Sure, yeah,
Data
um,
changes over time.
yeah, and it correctly models what it means to have um, some amount of like disagreement over what's happening in time, some amount of disconnection between parties that are modifying the same thing, in like who
It's
aren't
built
talking
for
to
that.
each other. Yeah,
It's built for
exactly.
that. And more importantly, the if you look at all the hideous amount of commands you could do, like cherry picking, branching, rebasing, merging, different types of pull request, all these things. Basically, the complete language of hash based or blockchain based data structures. So, the Ethereum chain, for example, never has to contend with, a multi headed 8-way merge like
Hmm.
Git does. Like Git's basically the owner of all of the merge space because they can do every operation. There's also some wonderful visualizers that show you all this happening. When I compare that to like the Ethereum block explorer that some guy made in his summer code camp 5 years ago that no one updated, that's kind of lame. Whereas like the Git ones are, there's a new one every week, right? So what I've kind of done, I don't know the best way to introduce this topic, but I'll just sort of keep chucking random things at you until something makes sense to both of us. Um,
Okay.
Here is. Can you see the screen I just shared?
Yep.
Yeah. Okay. If you take note of, can you see my cursor? No.
No.
You can.
No.
Okay. So down the bottom left, you'll
Yep.
see a commit hash
Yep.
by an author. The message is the commit message, and the time is the time since the commit time.
Yep.
This is me sending a message out to GPT-4. This is it streaming back in, and then once the stream has completed, you'll see it commit to Git, which causes the end of the transaction. So I've got this running in the browser, and I think it's a testament to the architecture that I could get back up to where we were with the entire Interpulse backend. I can get back there in 4 days. So
Uh, that's also kind of frustrating, isn't it?
you have no idea, like no idea the depth of my rage, frustration, and just all these problems. But um, it's working great. This streaming ability, you see the commit. You got a new commit hash down the bottom. And
Hmm.
it happened 6 seconds ago. So what the beauty of that was that I can use the file system as the transient state, and so the UI is able to give you the streaming status
Hmm.
as the LLM is computing in real time without it being a commit and requiring all the overhead of it being a block.
Hmm.
Um,
You were losing something there a little bit, right?
yeah.
Because it's not all happening inside Blockland, right? Like it's the catch up afterwards, like gives you an attack surface basically.
Um,
It because it's happening only here, right? I think it's like a very small attack surface, but like
oh, right.
the
Yeah. So you
like.
can what. I have had to make some simplifying assumptions, which is that calling an LLM via API is the same as calling an LLM via a deterministic, decentralized process where the GPUs are distributed. So there is a temperature setting and there is a seed function that you
Mhm.
can pass to GPT-4 that will give you back more or less the same thing for the same input. So in terms of
Really?
validating, yeah. So in terms of validating what happened, I could rerun this calculation with the same inputs
Hmm.
on another machine, and I should get the same result back.
I
Moreover,
didn't know there was a
yeah,
deterministic mode to it. That's cool.
yeah. Well, moreover, in PyTorch and the other and TensorFlow, you can set deterministic settings for the library, so
Hmm.
that if you were running the inference on your local computer, you would be able to reproduce the results regardless of where it ran.
Right.
Additionally, whilst I think the answer I'm giving you here is about the attack surface of this exact type of interaction, a more general response to your problem is the fact that we can easily make a branch and post periodic updates to that branch as the stream result comes back in, and then
Right.
ultimately do like a squash merge or some other type of compressive behavior to the main branch, because we want the history to look like it did move forwards in these big steps.
Yeah.
Happy New Year. Happy New Year. Happy New Year. So that's sort of that kind of streaming operation with the live update is, I think, solves a big problem that we had about the liveliness of the system.
Yeah. Yeah. Well, and I mean, like it also, I think it doesn't really matter that much, right? Because like most of the time, even if you're operating in like a massive group of people with like all sorts of different views,
Yeah.
like the thing you're doing as an individual is probably still something that you mostly only you care about until it's socialized, basically, right?
Right, but that's not to say that that's the only type of operation that you might want. Like you might want a the output of the LLM to be a shared and agreed upon response. If you were, just to pick a random example, reconciling gas trades between large corporations,
Right.
you might want to have that occur. So,
But
in
what
terms of
what I'm saying is, I think the way you would handle that is everybody would report their own branch, and then it would be like up to a multi-party merge to figure out exactly what the outcome is that could be
yeah,
managed through some kind of a more human UI, I guess.
yep.
I'm
Um,
yeah, I'm not sure. I'm sorry, I might be leading the conversation in the wrong direction.
so I don't really know what the right direction is, but so the idea would be that if you, for example, ran these inference jobs in multiple locations, then
Mhm.
um, you would everyone would pass around a merge request, and then they'd all sort of sign it and say, "Yep, I agree that this these two branches merge with no conflict," and then they sort of start circulating that, and now you've got this shared branch or the shared main branch, the
Right.
consensus branch in the middle that everyone's agreed to.
Yeah.
And that's the system state or the application state at that point.
Yeah. Yeah. I agree with that.
Yeah. And so the what we've done with the channels, right? Like the patents we filed on chain joining and the implementation and all the debate about what does Pierce mean, like how do you inject something from the outside in, and how do you side effect out once
Yeah.
you're in a deterministic, repeatable place. Um, the key concept there was this data structure called the interpulse, which was just a diff of the channel that was in
Yep.
the channels and all, right. So all that that's really trying to do is have two different work trees and merge them to agree on a single array of actions. That's all
My
it's ever trying to do.
my branch has my view of what I think somebody else asked for and did, and I need to reconcile that with your branch, right?
Yep. Yep.
So
Um,
like it's every single like node, like virtual node in this system. I'm just going to call it branch a node, basically. I think has the ability to have a view of what everyone else is doing, and that view is not necessarily like correct, right?
that view may be Byzantine,
Yes,
and so that, but there seem to be more ways that you can deal with Byzantine behavior if you all shared your Git repo than if you were just sending handcrafted messages.
right. So you know one way you could deal with that is you could say that the interpulse, the action, the thing in the channel, is basically a branch that is like shared knowledge, right? So I've created this
Yes, that's shared
action,
knowledge. Yeah.
and like the best way for you to know that you agree with it happening is to just merge that branch into your branch, right?
Yeah. So a transmission between chains would be the branch here gets a new action inserted in its array of actions, and it tries
Yep.
to PR against the remote chain's view of what that array used to be. And it says, hey, look, there's another one added here. The remote chain says, yep, it's all checks out. It's in the format you're allowed to. The data is correct. You got enough credits, all this stuff. And
Mm-hmm.
then it would do some processing based on that trigger. It would then create its reply or its settlement of that request, and then it would PR back where now you're saying the shared view of this branch uh, is now you've sent an action, I've sent a response. Do you agree? That's all the chain joining was.
Okay. Honestly, you know what? I'm feeling some feelings right now because it's actually a lot easier to talk about this if you just use Git branches to describe it.
Correct. So
I'm
much is easier. And I haven't even started on the performance gains. Like you wait till I get into the performance gains. Like it's ridiculously fast in comparison. So anyway, $17 million just to be back at the start line.
no, it's not though, right? Because it's like you have to figure out like some lessons. I think just have to be learned the hard way, right? You know, I think the lesson here is like if you live inside of a metaphor that everybody already understands, like it's easier to build shared language, right?
100%. But I don't think we knew that we could actually do this until having LLMs available meant that we could focus purely on what remains if all
Mm-hmm.
of the complicated code is removed. And what remains is a custom file system layer on that's designed specifically for high performance Git.
Right. It's a yeah. I mean, I don't know. Like I said, I'm feeling feelings. It's kind of shocking,
Yeah,
but
I know.
I definitely see exactly what you mean.
Yeah, yeah. So this tab I've got here. Do you see my do you see my
I
tools pop up? My dev tools, or is it just the?
I didn't know. It's
No, you
just the
don't see my
screen right
dev
now.
tools. Okay, all right. Anyway, there's a really good library called isomorphic Git. That's what's driving this application in the browser. It is compatible with GitHub. Like it is version one of the Git protocol.
Wait, so it's you're running a repo in
Live,
JavaScript?
correct.
Oh, cool. That's how did I never find that?
I don't know, right? And then, um, so the model I followed is that you can do anything you like in the ephemeral file system, but when you go commit, that's when you've sort of made a snapshot of system state.
Mhm.
And so the agent or the actor that does that is represented by the system process that's executing. Now, I just want to jump into system processes very lightly.
Okay.
I think there's no such concept as every chain having a channel or multiple channels anymore. What I
Okay.
think you have is you have a data structure that I've called an I/O that simply you can you can drop that down anywhere you like in the file system. It's simply the channel format, which is like what channel count are we at, what's the array of actions, which ones have replies, all that. So it's basically just the chain joining channel structure in a single file,
Yeah.
and then there's a a data structure at the root of the repo that, for lack of a gender neutral term, I've just called Procman, which is the process management data structure that is meant to be sort of like / proc in the POSIX file system, but it you remember this concept of tension where we were talking about, like, if you had to halt your execution, you may have a bunch of unfulfilled promises down the stack that you need to pick up once you next get a slot on the CPU.
Yeah.
Yeah, and so the procman is basically the way to register. I would like a function to run. Here's the channel that's providing the inputs for that function, and then the function basically has to register back its results or where it's at with Procman, so that it's all taking place in a managed way.
Yep. Makes sense. And Procman is um, inside the branch state, or is it outside the branch state? Like,
It's
is it
a
inside?
committed file. It's a
Okay.
JSON file that is committed in the in branch,
Yep. Okay.
right? And then when Procman detects that there's been a new action, Procman will make an instantaneous fork. So this is where the file system customization comes in.
Hmm.
It will pass an isolated view of the file system off to the process that's about to execute. That process would have been locked down with what areas of the file system it can access and it can read from and what it can write from. But because it's like an instantaneous snapshot of the file system, it doesn't matter anyway, because only that process is changing anything in the file system anyway. Once that process has completed its actions to the point where it either completes or is at an intermediary stage where the developer has deemed it's worth taking a snapshot, it will attempt to do a commit back to main with its updated changes that it's made to the file system
Hmm.
and to its queue of actions.
Main, of course, being main for this application, basically, or main being
This
um,
complex. So each complex is now a repository,
okay.
and you can have, using the Git submodules type of structure, you can have they can be mounted anywhere you like, but the repo is a consistency boundary.
Okay. Yeah, I agree with that. How are you dealing with like, I guess there just is no such thing as all of the things inside of the repo having their own consistency, having their own timing, having their own, you know, it used to be the case that a chain complex, all of the chains inside of it, like, could be run independently, one at a time, if you wanted.
They can be, and that's the procman tracks every process that's doing concurrent execution.
Okay.
So you can have arbitrarily many computations occurring that could be across many machines, but they all need to synchronize back at the choke point is even deeper than the choke point being the repository. The choke point is the procman file in the
Right.
repository. You can't go faster than you can update that.
Right. And so it leaves it open to say, like, if you want to leave these things halfway done, they're basically just branches in the repository until, we create one massive merge for all those processes against the whole repository.
Yep, yep. And so in that way, what I've managed to do, the work I'm going to try and do this week, is this model simplifies how we were doing isolation. So I can actually load up from the repo. I can load executable files, run them inside a web worker,
Yeah.
and then report the results back, and then merge them back into Git. And so how to isolate these processes was always a massive pain for us. How to look up or retrieve covenants, how to reify covenants, all that stuff was a massive pain. That is remarkably simpler in this design.
You know what I like about it too is because it's all like using POSIX metaphors. Like when you go to move it to an actual Linux machine, like Docker works the same way as a web worker.
That's right. That's right.
You're just
All
you're
works.
gonna when you pick up Procman, you're gonna share the file tree that's allowed for this computation into a Docker
Correct.
container and just let the
Yep.
thing go
Correct.
hog wild, right?
That's right. That's exactly right. So
Yeah.
that I think that um, if you overlaid the Docker metaphor with the WASM metaphor with the web worker metaphor, like they all have that overlying boundary that they will be presented with some file system, some executable, and all that. And we used to sort of have to fight with in the spawning thread. You had to give it access to the module file or files that you wanted the web worker to import.
Mm-hmm.
That was always quite a menace. But here you've just passed the whole Git repo or the whole file system down to the web worker and just given it a path within this repo. It then fires up and off it goes.
Mm-hmm.
So it's having the file system there allows pass by reference to these isolated areas instead of having to pass because your program exists on disk in inverted commas. You can
Mm-hmm.
pass the whole program around just by passing a POSIX path and a commit hash, and that's different. That's grounded.
Yep. It like it makes the like code loading semantics really simple too.
Dead simple, like stupid simple, and it also makes it extensible because you can specify the code to be loaded from npm, from a CDN. You can pull from a Git hub URL based on a commit hash. Like you can pull from, you kind of don't care where you pull from at that point, which is what we wanted. And the only real knack is that, for example, if you wanted to run a Docker container, you just need a different loader. So instead of the web worker loader or the node worker loader, you'd call in the either web container or web worker loader. And then, you'd suffer the restrictions of that. Like you can't run that in your browser, but that's sort of the point is the framework is the same.
Mm-hmm. Um, okay. Yeah. I like it all makes sense to me.
That makes sense. Okay, so what I've gone and done is I've made a mapping between the Git functions and concepts and the functions of ours that we need to make sure we meet.
Okay.
So the author of a commit, obviously commit is pulse.
Yep. Yep.
Author of a commit is the process. It contains process information. It's not an author as in a person. It's what is the identity of the process that committed.
Yeah.
A complex is now a repo.
Yep. Now,
Side
I
of
guess what Interpulse is like, they live in independent repos. Like, I'm just trying to get a sense of like, this is something that doesn't quite fit one to one on Git, but like you could force it to, right?
say that again.
It's suddenly
In, so interpulses seem to need to exist in a state where they're like between things, right?
What do you mean? Sorry, because
Yeah, it's okay.
what is the purpose of interpulse in this system?
So I mean the actions, the impulses that are coming from one repo to another, like they live in an independent repo that has its own life cycle, or no?
Uh, are you talking about when you want one complex to talk to another complex?
Yes, yeah.
Yeah. Okay. So in that case, the the sender. So we used to try and make these channels be bidirectional.
Yep.
In practice, I never actually had any use for bidirectional channels. It actually, you only ever need to go one way. And it's rare, like the communication in is unrelated to the communication back because request reply is independent of who initiated the communication. So the we currently had it that anytime you open a channel, it's bidirectional, and
Yep.
both directions have another two channels on them, which is the request reply channel.
Right.
Yep. In practice, you only ever used one of those. It was rare to need both.
Yeah. Yeah. Right.
Yep.
So
So,
like promises versus like some kind of streaming abstraction, like a generator, right?
well, generators, I now believe, can be served by either a branch with a squash merge,
Right.
um, or if it's local, like if it's a generator effect within the current complex, you just write to the file system, and the file system represents that transient intermediary state that ultimately
Right.
gets compacted down here. So two ways to do it, depending on what you want, and depending on, it does appear to be rare that you would want to have generator-like updates to
Right.
a remote repo. But this will all shake out, and there's options. We've got lots of options.
Okay. Yeah. So, but what if I understand you right? What you're saying is that the responsibility for the interpulse lies in the sender's repository, and you're allowing access to the receiver to write into the sender's repository,
The
basically.
receiver is getting pull requests made by the sender, where the sender is trying to PR against the the channel queue structure,
Right.
and they're also receiving pulling down the the receiver is in charge of that object. The sender has its own version that it's trying to insist on being merged into the receiver, and then as the receiver updates it, the sender pulls back the response.
Could you say it one more time? Sorry, I gotta close my
Yeah,
eyes. I
no
gotta
worries. Yeah,
really visualize.
the the sender
Mm-hmm.
has a copy of the data structure inside
Mm-hmm.
their local repo. They are trying to pull request that single file against the remote repo's location of that file.
Right. And then the receiver like chooses whether to merge it, acts on
Yeah,
it, and
yeah.
then like changes the data structure,
Changes
and
it. Yeah.
then and
Triggers
then it,
triggers it. Says, hey, you need to pull like a fetch. You need to do a fetch on the sender side. It's like this
yeah,
file has updated. You need to fetch it. The sender pulls it in and then merges that back into their local view of that file. So
right.
you've got like a Venn diagram where there's this one file actually
Mm-hmm.
is made to exist in two places,
Yep.
and
Yep.
that's effectively the portal where information, the receiver sees it as information magically popping up, and the
Yep.
sender sees the replies popping up.
Okay. It makes sense. So they're not. What I was asking basically is they're not in some sort of third repo that both have
No,
access to. They're literally just
they're
shared
just
state in
files. They're
okay.
just shared files, shared JSON files, and how that changes things is that where they appear, we used to have it that it was channels everywhere. Every chain had channels every single where. But
Yeah.
now it's really just those channels only appear randomly within the file system where they're required.
Yeah.
Otherwise, it's just CRUD.
Right. And realistically, the way to think of it is it doesn't make sense to even put them all over the place. It probably makes sense to just put them in one place in the repo Like they really
I
kind of
think
belong
that
to the.
I think it's relevant to put them in arbitrary locations depending on your program purpose, but I think that I don't know for sure, and as I start to use it, and particularly as I start to integrate the Procman um, process management with this channel system, it will become apparent that yes, they should all be in one place, or not. But the deeper either of those options is easily explored, and it's
Mhm.
not like a massive fundamental data structure
Right,
rewrite
right,
to
yeah,
put
yeah,
it one or the other, right? Like it's
because it's a
beautifully
fun.
simple.
Yeah. Pardon me. Give me a second. I just have to
Yeah,
go take a
sure,
bio
man.
break here. Okay.
Yeah, no worries.
All right. I'm back.
Alrighty. So what I'd like to show you now is how simple that becomes inside React. I can just find a place that actually did it. Okay, so here using React hooks, I can do this. Can you? Is this clear enough?
Yeah.
Transfer. Is that alright? Yeah. Okay. This hook use artifact JSON specifies a path in the file system that I'd like to have inserted into the React component.
Yeah.
This every time this thing changes, this file will update, and I intend to add decorations to it, like its status. You know, is it simply in the working tree? Is it in the staging area? Is it committed? Has the commit been distributed widely around? Um, all these types of lifecycle updates. But
Yeah.
in,
Yeah.
inside React, that's dead simple. Um, the overall the overall system is specified simply with this. I make a provider, where that's the artifact provider, and then any any component within it can use the hooks to access the files that they want, get live updates on those files changing, um, access the prompt. So that's really good one to show you. Um, here I use this hook, use prompt. Simply gives me a function that allows me to inject something into that io.json file, which triggers the
Yeah.
yeah. So that's all of this is just dead simple to use inside React using these hooks. Like
Yeah.
stupid
I
simple.
like it. it's just hooks, right? Like
It's just hooks,
there's
man.
no messy tangled logic inside the component.
No, dude.
It's like that means it's all very like orthogonal, right?
It's completely independent of what the hell is going on
Yeah.
under the hood for the blockchain. If I can do the consensus mechanism like I described earlier, the consensus mechanism will use the same types of tools as what these apps are using anyway. Um, so the hooks I've got use artifact. That's just simply here's a path, give me the data that's there, the raw data. Use artifact JSON. I've declared what the format of the data at that path is given to me. Use action is where you sort of pull up that IO queue and you get functions that you can call within it. Use prompt is just a special wrapper around uh, use action. I haven't, because I'm in sort of prototype mode, I haven't implemented that here, but that's really just going to be a wrapper around use action once I
Yep.
implement the IO stuff. Use commits is a way to get the list of, basically that's the same as getting the pulse history, which will allow me to see the commits and then go back to a particular state, recover it, proceed with reinvigorating the procman at that point, because each individual process is isolated from all the others anyway, going back in time and to a different complex state and then initiating the procman again. I don't need any more isolation for that. It's just the same isolation that I always use all the time. So I
Yeah.
now achieve that ability to recreate a past history and carry on execution from that point without any problems, which seems insane. Anyway, and then this is the hook. Use latest commit. That's what I used to show what the latest commit was in the UI. But again, it's just a wrap around it. So, look, man, everything we wanted can be done in this way, and it can be done dead simple.
Yep.
And that's completely ignoring the benefit that we get from using the LLM to execute the complex interaction logic of the app or the consensus or the network. So even if we were to build interblock on interblock like we always wanted, and we did it this way, it would be remarkably simpler and easier to not only build but to implement. To explain to
Right.
people um, with more features sooner, like isolation, ease of distribution, um, rapid diff-based syncing. So when a browser fires up and it's been offline for 2 days, it only needs to pull what it missed out on since the last time it synced. That diffing is all handled by Git. That was actually a month and a half of me trying to figure out how to make that work effectively in the browser, right? Complete waste of time. Like, complete waste of time.
Yeah.
Um,
Actually, something I don't know. When you're talking about PRs are a construct that like your Git provider provides, right?
correct, correct.
It's
Yeah,
not
so that's
actually
an
baked into
example.
Git.
That's right. That's right. So that's an example of where the procman is used to execute the process that goes about negotiating a merge or requesting a merge from another computer. So we would run that construct, and we would need to run it using a derivative of the Tenderman algorithm or similar to be able to merge in consensus. And now, all of this is really to say that I think that we can get a fully functioning test net up using this system that has enough scale that it can actually handle. You can feasibly say that right now today I can handle maybe 2 gigabytes in this system.
Hmm.
With a bit of tweaking, you probably get to a terabyte because it's all just collections of Git repos.
Yeah.
If we're able to run the consensus mechanism using LLMs, so that means no coding, that means the algorithms are understandable in natural language, we could get You could see a testnet version in weeks, really. So that,
That's really cool.
yeah, it's a little scary because effort is a form of protection, and
Yeah,
so
yeah.
like if I can do this as fast, so can everyone else. Um, so we're just going to have to see how that plays out. Um, but
Um, yeah, I mean, like, again, I mean, my answer to that is always like this is so close to the actual like math of everything that like any
yeah,
other attempt to do it is going to be
it's going to
similar
just
enough.
it's going to just arrive at the same point. It
Yeah,
really is. Like,
it's going to be similar enough that you should be able to swallow anyone else trying to do the same thing, like
yeah,
even with
that's right.
only weeks of head
That's
start.
right. Yeah, yeah. So I think, and I appreciate you to give me some thoughts on this over time because
Yeah.
it's a complicated, confounded question. I think the way to win becomes a money race where because we can swallow anyone else, but we can also be swallowed. Whoever can
Mhm.
go out there and raise the most capital, get the most utility flowing through the system, is the winner. So that's where I'm at in my head as to sort of how does the race look if suddenly like it's easy for anyone to participate.
Mhm.
It's kind of comes down to who's using it the most.
Yeah, yeah, and again, like what applications are actually capable of running on it. I think there's still some stuff to be solved in the land of like, can an LLM intermediated um, program, like distributed program, actually like allow me to manage things in a more coherent way than any other tool that's out there right now?
I am going to bet a lot of money on that,
Yeah. I
which
also think it's true. I think that people will take convincing. That's all. So there is like a bit of a like
I think if
protective
we can,
factor there.
yeah, 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 yeah. So let me show you where I got to with the distributed GPU stuff. Um, this is a project called Petals. What they've done is these. This is the Beluga 2 model. This 2.x tokens per second is being generated on distributed consumer GPUs. They've been able to take, I think the 70B model is, they've sort of squashed it down to use 6 bits of compression, so I think it's around about 38 gigs of data. So
Right.
you'd never run that. There's no consumer GPU that could run that in one shot.
Right.
What they've done is they've made a mechanism that can take PyTorch inference data,
Hmm.
split it up into layers that are small enough to load into consumer GPUs, and allow a network of GPUs to form these pipelines so that the summation is the equivalent of having run it in one spot.
No way. How is that? I can't even imagine you can split a model up like that.
You can't because all the models have layers. Um, so, I mean, look, obviously I say you can because I know because I've seen this thing, which isn't really a fair thing to say. So, let me now take you to the network health. Here's the machines, and if you look at the server ID, you'll notice that looks a lot like a libp2p or IPFS
Yeah.
node ID. Um, and then yeah, this is the health or how available they've been. So it's sort of like BitTorrent, um, and then it distributes the blocks of that it broke the inference model up into. It spreads them around between the machines, and then allows me, the requester, to arrange them in a pipeline and go you talk to that, talk to that, talk to that, talk to that, talk to me, and then that's how you run your inference. And if you look at like this guy, he's smoking, right? That's 1,000 tokens a second. It's a pretty beefy machine. Um,
Yeah.
but ultimately, I'm limited by the slowest machine in my pipeline, and so
Yeah.
as you saw, I was getting like 2 tokens a second. But the point is that it's distributed.
But that, yeah, I mean, that's also a different type of distribution than the other, higher level distribution that you're talking about with lots of repos and lots of like independent projects talking to each other, right?
Right. I
I,
believe that this project, this networking model that they've got, could be managed using repos plus LLMs to negotiate and arrange these pipelines.
right.
And so
That would
it's
give
more,
you like, that would give you like almost like neuroplasticity for the cluster of things that are interacting in an application. It's
it's very plastic.
really cool
It's
idea.
it's it's
Mhm.
very very plastic. Yeah. Um,
Mhm.
so what I think that means is that we used to talk about packets and we'd use these NFTs to capture the funding model of them. I think that I can model that whole thing in Artifact now, and then I
Mhm.
can just bridge funds in from other chains. Like if I want to bridge USD in, I can just it's rather than trying to write it in Solidity, I can bridge the funds in to Artifact and then write it in Artifact.
Yeah. Yeah. I mean, anything that sidesteps existing blockchain infrastructure is a positive, in my opinion. Uh,
Absolutely, absolutely.
you could also probably just wire like a Stripe gateway up directly, right?
Yeah, but then you get issues. You'll have compliance issues around those gateways. Don't like you running a what's the word for it? Like Upwork has a very special type of compliance. Like they don't payment gateways don't like you running marketplaces for labor because it can be used for money laundering.
Of course, yeah. Because like,
Because
it's very up to the like observer what labor actually is, right?
that's right, that's right. So you can sort of sell something that's hard to tell if it had genuine value, and then that means that you could just be washing money through the platform. And so that's a no no. So that's sort of a problem. But um, I, we know a lot of compliance people, so I'm sure we can sort that out.
Right. The point being, of course, like if you need a like a quick and dirty path for money to get in, like you could use crypto, but you're now
Yeah,
no longer beholden to like consensus and NFTs
that's right.
being on that crypto, right?
That's right. That's right. That's right. That's right. So, and then all the complex operations that we were trying to do within Solidity to make the NFTs sort of like shared or
Mhm.
dynamic. You can do all that computation in Artifact and then just bridge back the result so that the data structure on the Ethereum side becomes dumb, like very very dumb, but it's just controlled by Artifact, which I think is a nicer way to a much nicer way to code. I think.
You know,
So that's it, man. That's where we're at.
so, something that occurs to me is if you're able to get to like a big and meaningful enough operation, like human meaningful enough operation, um, by using the LLM as the go-between,
Yeah.
then maybe you don't actually need a complicated consensus mechanism on sharing like actions between applications or between repos, complexes, whatever. Like maybe you could actually just use like the normal PR mechanism on GitHub as your consensus mechanism because like at least in theory the LLMs should be making things like leveling them up a lot from like low level operations to high level meaningful human things that like a human might need to make a choice about.
Um, yeah, you could, but you still have the issue of it ran on someone's machine, and that
Hmm.
machine can be corrupted.
Yeah,
So,
right.
so look, I don't think it's nearly as big a step as what we used to think to achieve genuine consensus using this mechanism. I think it's sort of just decreased by at least tenfold, maybe 100-fold, to be able to get a reasonable level of consensus that we can trust operate in the wild.
Right. This is exciting. I
So,
feel like kind of like there's a lot of neat ideas here.
yeah, and I think um, it also results in a more long-lasting data format as well.
Mhm.
Because if you want to try and pull data out of the Ethereum blockchain, it's an absolute nightmare. Like that data structure sucks. I hope it
Mhm.
goes down in history as the same way that CVS was ridiculed once Linus put out Git. Like it's a I won't say a bad data structure because it served its purpose, but I hate it and I never want to work in it. Whereas here, it's like it's just text files, and so any browser can fire up, and you can access that data and process it any way you like. If so long as you can use Git, a file system, and interpret the data structures given to you, you can write an app. It doesn't need any esoteric knowledge or anything fancy or anything like that. Like it's very very inclusive to all.
Yeah.
Um, so look, your review sounds positive. I'm not hearing anything that sounds like what did we miss or what did we lose.
Yeah, I mean I can't think of anything. I know it's like my view on this whole project is it always kind of tiptoes up to the point where some complicated network thing like consensus needs to be implemented, and
That's right.
then like that becomes really really hard.
That's right.
Um
That's right. I think
I
that
think
I can show here that it doesn't matter
mhm,
and that it's free to be solved independently.
yeah, which I mean I actually because it's all cast in a language that I think is a lot more comprehensible to developers of like this is how your Git repo works.
Yeah.
It's a lot easier to convince people, right?
Yeah. So what I'm
Uh,
planning to do for the tracking application is I'll set
yeah.
up a private repo on GitHub, and every client will push to there whenever there's a commit, and that's the backup of the
Mhm.
system. And from there, they only need to fire up their browsers, and they'll be able to operate. I expect they'll be able to get the browsers to talk to each other, so they can go offline, like disconnect the internet from the site, and the browsers should still be able to share updates with each other locally. So that was a feature that, in hindsight, was going to take a gargantuan amount of effort. I think
Mhm.
we can get that. You know, it's weeks rather than years.
Yeah. Um, I assume for now, like you're basically using GitHub as a host for everything too.
I haven't pushed back to it yet, but I think I will do just because the stable, available, the protocol's compatible. So the current architecture will be just there'll be like a governing computer that is the authoritarian figure on the network.
Yep.
All the clients have to, instead of doing shared consensus, it does iSensor consensus, and once it reaches consensus, it pushes up to GitHub, and that's the backup or distribution. Um, and the consensus is just handled by a single server on site.
Right.
So you can recover from that. We can replay faults by just going back to a particular commit and then executing the procman at that location so that we can debug whatever weird was going on with the LLMs or any other code. Um, that was a feature that we talked about for years that we never actually got to do. That's available now.
Right. What I guess I mean that does leave a bit of an open question for me. What about when you want to move to decentralized operation? It's basically just using like a non-centralized Git repo, right? So like
Yeah, I think
switching
it could be.
everybody to be different origins on the same repo
Um, I think what
or
you
different
end up
remotes. I
doing
mean,
is you want to do, let's say there's four validators.
hmm
Each one has their own branch. From their point of view, it's called main,
right.
but the hash ID, which would be like the content hash plus their signature, would be different for each of them.
hmm
And so what they're always trying to do with each other is they're always trying to merge each other's branch into theirs and get
Yeah.
theirs merged into everyone else. And so consensus is the highest commit that everyone had merged into, or that the quorum had merged
Okay.
into.
Yeah, that
And
makes sense to me.
yeah, that
Will you?
negotiation is handled by just sending messages around in like a poker.
Right. Have you ever run like a repo with multiple remotes? Because that stuff is kind of all done for you already in the remote feature in Git. Like everybody has their own main branch.
Yeah,
Like each one treats the others. Like when you're running Git on your machine and you say like pull, it pulls down a branch called origin master, and then you have a branch called master, which like they're not the same thing. They're
that's
one
right.
is
That's
the
right.
view of master on the
That's right.
origin.
That's right. That's right. So it's like, I see what you mean. So you're really just saying that you'd update the tracking file to point
Yeah, you.
at. Yeah. Yeah, okay. Perfect. Done.
But the bigger problem there is just like what does it mean for the tip of the
I think
application to move forward? I guess right.
yeah, tip is subjective. It's the latest thing that you can see and that you agree to, and
Right.
that's all it's ever going to be.
Right. And so if you wanted some fairly objective sense of like what is this application doing, you need to check in with everybody's main basically.
As many as you can until you're like, yeah, I trust this guy and that guy and that guy, and my confidence is 99% plus, and it just keeps going up.
Yeah. Okay.
And I genuinely think there's no limit to the size of complexes that you can have and manage in this system. I think it's an extremely data efficient way of doing things. It's a
Yeah.
really code efficient, particularly if we harness the LLMs. It's very little code to be written. It's inclusive in that the algorithms that define the the consensus mechanism will be natural language descriptions. And so ideally, I want to launch this chain with the speciality being that this is where you can author and host natural language defined applications. So you
hmm
can do arbitrarily complex things, but you're just doing them in natural language and you're able to tweak them um, using that natural language. So,
hmm
even just filing an issue is just a natural language description plus a git commit, and then the LLM should be able to execute it from there and be like, oh, whoops, So um, I think that's really that's the pitch. I don't
Okay.
think you could be any more AI native than what I just described.
One thing I'd still would love to see in it is use the AI to generate. Like the fact that you're running this in a JavaScript environment kind of just begs the question for me. Use the AI to generate some kind of interface that you then like run in React that becomes like a normal 2D kind of graphical UI for you to
Well,
interact with the
yeah.
data
So
with.
that's what this is. That's what here this off the side. That's the
hmm
stateful. I haven't hooked it up yet, but basically that's just a uh, that renders a markdown file that the LLM writes to based on the chat.
hmm
So that's the stateboard is what it presents back to the user that
Right.
it's like.
And can it make like interactive elements?
Yeah,
Can you
yeah.
get it
So
to spit out maps that you can like draw circles on
yeah,
and stuff like that?
yeah, exactly. So two hard problems that occur in the tracking app that you can't do with chat. Number one is drawing a polygon on a map, and
Yep.
number two is reordering a set of elements. So for them, it's like the pickups need to be reordered manually
Yep.
for human optimization. And so you can't really do that in chat. So I will present a graphical element in the state board that takes the human interaction and turns
Yeah.
it into text so that it then goes back to the LLM to then process and update the board.
Right. So one what like I mean, is that an element that you're shipping as the application developer? Or is that something that like the
Uh,
LLM cooks up as
that's a good,
JavaScript code?
yeah, that's a good question. I don't trust the LLM to cook anything up and get it right first time.
Right.
I would also not be shipping that element with the base application. I would be shipping it as a pointer to a hash so that the Git file system knows how to pull that in and then
Right.
loads it up because it would run that stateboard in an iframe so that it could use external components without breaching the system.
Yeah. But that's suitably sandboxed enough that if the AI can start actually creating GUIs on the fly for you, that like that's an
If it
okay
ever
space to
can.
run it in.
Yeah, yeah. So I want to get to the point where the AI has a good set of tooling that it can make little components and test them on its own.
Yeah.
But that I think will take a bit of uh, clucking
It's gonna
around.
be it's gonna be a while, right? I don't like they're still not that great at coding something that's actually big enough to be useful to people.
Well, that's the thing though. When you run it in little tiny nuggets like this, they can often
Right.
get that right. And in
Yeah.
particular, if you sit there and chat through what's wrong with the component, then they will get there. So
Right. But
um,
just I'd want to ideally have it built in a way where like whatever repository of cool UI things that it can pick up and use exist, that those could eventually be treated as like a hint for how you might build something on the fly. Because I genuinely think like an adaptive
yeah, that's a good
interface
idea.
is like
Yeah, yeah. So
uh,
it's like well, this is a known good tested high reputation element as a starting point. I need you to modify it to have these additional properties.
yeah, and I mean, ideally, it would be eventually figuring that out for itself. Like, this has been used with this type of data many times. Here's the way that like the schema of the data has changed a little bit. Here's how we
Yeah,
might like pick up other pieces that map out
yeah,
that
that's right.
schema.
So what's important about where we choose to put our markers down here is that we must be able to benefit from the expanding capabilities of AI. And
Yep.
this
Yep.
system, no matter what AI evolves into being able to do, I feel like this system will remain relevant.
Yeah.
And
I broadly agree because you're trying to turn the individual compute steps into the smallest possible thing. So like it's
yep,
easier to build up from small things than it is to build some massive monolithic thing, right?
all all things of merit are built from small things of non-merit.
Mhm. And like there will eventually be a point where like an AI would either through conversation or like just generating an application like a GUI for you will be able to kind of be a good go between to any type of data that you want to manage
That's
as a
right.
person.
That's right. And
Uh,
so a long-standing problem will always be consensus. Am
mhm,
I being lied to? Is this correct? Is this globally correct? Repeatability. Did my AI run correctly? Uh, Externality. AIs will always be expensive to run, and so I
mhm,
need to draw on external capacity to serve my needs now. How can
mhm.
I do that in an efficient marketplace in a timely fashion? Um, and data integrity. That's not going away. And
Yeah.
if we can make everything else disappear, we would still be winning under this model.
Mhm. You should write those down. The 4 points you just listed.
Right, right, right. Okay, and
It's
that's where we're putting our money. That's where we're putting our bets. Is like, AI will eclipse everyone who's not building those bits.
yeah.
All right,
Yeah.
well that's pretty much that was it.
Yeah. Well, I mean, I can't even imagine what you must be feeling right now. Like to be able to rewrite the whole thing in like a week or two. I
Well,
mean, that's either that means that you've done it so many times now that you understand how to do it that quick, or you know, maybe scarier is that there was never a problem to begin with that wasn't already solved.
oh, that's cold. That's cold.
But but I mean, come on, man. Like
You're
I
probably right, though.
I've been playing on computers since I was a kid, and I felt like all these things were like real problems that need real answers. I think you
I know,
shouldn't.
man.
I'm
Yeah, I
I'm
know.
not trying to. I'm not trying to be like. I actually genuinely do think it was that quick for you because it's become second nature in your head.
Right, but I think what's frustrating is that the answer was always there right in front of us the whole time. But I think we couldn't see it because um, LLMs arriving allowed us to imagine pushing all the other code out to the LLM, and that's what allowed us to unearth what's underneath, really. I think.
Right. I want to like. I almost wonder the interaction, the specific interaction of like I'm adding stuff to your repository. Um, you know, I don't know if I'd try and build that off Git submodules. Git submodules are an actual nightmare. um,
You mean like when you want to push an action into the queue on a
yeah,
remote complex? Yeah, but
right.
that's the way I would do that is not with Git submodules. It would be with a what's called a light checkout, where you
Right.
just check out just that path, and then you modify it, and then you just try to push that one back in. Now,
Right.
either way, if Git under the hood doesn't allow that easily, I'll just make a small piece of code that does that for you.
Yeah.
That's trivial. It's just
But
like,
what I'm trying to get at here is I think that like that's such a mind blowing thing to be able to add to Git that I think we'll have so many applications even in normal coding because it's like a different way you could manage dependencies in an application. Um,
can you explain that to me?
like I mean, right now, how do we do dependencies in JavaScript land? We run some sort of third party code that,
Right.
at least ostensibly, is supposed to be like hashing everything and doing security checks and telling you when you're out of date or
Ah,
whatever,
but you're
right?
saying that actually NPM should be part of Git checkout or Git clone. Git
You
clone.
could okay. So what I'm trying to get at is like when you build that piece, like have a mind to turn it into an actual Git plugin because even in normal Git with normal developers, that piece might actually be something that's very useful.
So you're saying that the node modules folder could be considered an extension of the Git checkout, so
Yeah,
that
yeah, right. It's saying if a library developer had some sort of a claim to like modify code in my Git repository, like it kind of inverts the control that we have right now for
so
like how
you're like
libraries are included.
so you just give it like the Git the sender of the remote
Mhm.
package, and then
Yeah,
your that Git plugin goes off, fetches it using Git, and just puts it in that
right.
sort of
And like now
control.
it disintermediates a little bit. Like it removes the need for me to go and publish to another third party of npm that the semver has changed here and have some sort of script saying like, oh,
It's
like
actually a
you should.
nightmare, eh?
Yeah, it's you know dependencies. Like I kind of wish people would learn Git submodules because it's actually like a more pure way of doing dependencies.
Yeah, but
But
the tooling around it sucks. So what you're
yeah,
saying is
it's
that it's like
brutal.
you're saying that it's not really it's like a lightweight submodules
Yeah, it's a lightweight
specifically
submodule that leaves you in like a clear
not for
understanding
code
of
but more
control.
for data, more
Yeah,
for data than for actual code.
yeah.
Right. And that's
However,
yeah.
however you build that piece, just like you don't need to do that, right? But you don't need to add it as a Git plugin. But if you keep it in mind that it could be made as a Git plugin, I think
Yeah,
it's
you're
like an
right.
interesting alternative to submodules.
Right. And then anytime so if I'm on the sender side, I modify the file. When I go git commit, as part of its task, it will also do a push out to that remote repository with that
Mhm.
just that one file or folder that was marked as being a remote, and then
Yeah,
right, and then the other side would see that as a almost like a pull request against it or something like
right.
that, and then when they include it. Um, and when they do a commit, I would get a signal back that this little splice has changed. It would be
Right.
sort of like what was that tool that um, we used, or that I made everyone use, and
A
that
bit.dev.
yeah, yeah,
Yeah, it's
a
like
little bit like that, right?
bit.dev. Yeah, bit.dev, but baked right into Git. Like
Yeah,
it's a really cool idea that like I think even by itself like would be a useful thing for some developers for sure. It might be like it
yeah.
might be a way to get people interested in the using the application like you're using the Dreamcatcher system. You know?
Oh, right, because you could actually have your Git commit trigger a remote process like GitHub Actions,
Yeah.
and then push or commit back a response that
Hmm.
was just appeared back in your repo, but didn't actually change master until you accepted it.
It's like a native Git to Git like Git repo to Git repo communication system, right?
Right.
It's that
That
doesn't need
involves.
all these like extra third party tooling, basically, right? It's a
Right, yeah, because it cuts that whole nightmare out, and
yeah.
it makes the provenance of the software supply chain closed, rather
Hmm.
than like go out and trust these guys. They go over here, trust these guys, and then it comes back. It's like no, there was no. It was hashes all the way through.
Right. I mean, it doesn't remove some of the problems. There's still the problem that somebody like stupid or evil has been involved in like modifying the foreign repo that you're using as a dependency. But
Yeah, but
you know,
at least the surface area or
yes,
the indeterminacy of the system was radically reduced.
yeah, right. Anyway, food for thought. I don't know. It's
It's pretty good,
I'm
man.
very glad that we could talk about using the like Git metaphor maximally here because it
Yeah,
actually does help me understand the system better.
yeah, me too, man. All right, well, if you can't think of anything that I've missed, I'll just keep blazing on with it. Um,
Yeah, not off the top of my head, really. Is it in a new is it in a new repo? Are you still in
yeah,
the
no,
Discord?
it's in a repo called it's in a brand new repo called Artifact in the Dreamcatcher team.
Let me see if I can. I'm glad GitHub actually finally used added a multi account.
You want me to send you a link to it?
Yeah, that'd be good.
Yep, chuck it in the chat. Good. So small. I have no idea. It's so small.
Nice. Awesome. Well, cool, man. Good to catch up.
Likewise. Okay. Alrighty. Well, I'll carry on and I'll let you know how I get on. I guess. I think we might.
Sure.
Yeah.
Have you got a test application in mind for the AI part yet?
Yeah. So the first thing will be for the tracking app. So um, I've gone through all the code that I had written in Covenants to make that
Hmm.
system, and if I drop all the schema from the databases
Hmm.
and do the format control in the LLM, plus if I do the date calculations, like okay, what customer is due on which date, that's definitely an LLM achievable thing. So I'm basically able to drop all of the. I think I can drop all the actual code from that project except for the UI elements, like the map, the polygon on the map, and the sorting. And I think I can drop every other piece of logic in the whole system.
That's cool, man.
It's crazy, right?
Yeah.
And what that means
I
is that the business rules are now visible by the business owners, and they can actually experiment with changing the natural language rules that they
Yep.
use to operate the system. and see the results. So I'll just work with them on how to specify the natural language rules sufficiently, and that's the both the spec and the program.
Right. I mean, that's obviously like the main, achievement that AI can give here is the spec is the program.
That's right.
Yeah.
That's right. And it's ready to go basically in real time. Like as soon as you're all happy with it, you're off.
Yeah. Well, that's awesome. I should show me a demo when you've got it all ported.
Absolutely. Can't wait. I'll probably I'll probably start a I'll be basically coming around to see everyone in person once I have that system running. So roll through Canada, do the west coast of America, and then over to Europe and London. Because at that point, I'm like, this that's enough. Like that's that's enough, right?
Time to go to sleep for like 6 years.
No, it's time to raise some capital. That's
Right.
that's definitely something that's worth amplifying. That thing.
Well, I've been trying to worm my way into more of those conversations too. So maybe I can um, maybe I can even know some people to help with that at
Yeah,
some point.
absolutely, absolutely. But I definitely want to be listed because this project all along has had a lot of people being like, "Hey, I want to put money in. How do I do it?" And I'm like, "Well, are you an accredited investor?"
Right.
They're like, "Oh, well, no." But and so if we're listed, then it's very easy to say, "Look, if you like what the system does, but you don't understand how to contribute directly, um, we're not doing a token. We're not doing anything crappy like that. We have a public listed company. You can buy shares in that.
Right.
And we have obligations to our shareholders that are legally enforceable in that way. Like it's a
Yeah.
legitimate investment at that point, and then it allows us to carry on with our uh, work-based remuneration schemes independently of fundraising.
You could go fully in the other direction and just make a Kickstarter. That's a joke.
Yeah,
It's a joke, man.
yeah,
I think a public company is a good idea because, like you said, like it just really um, increases the um, believability. I mean, the enforceability.
yeah.
It just makes it more real, right?
That's right. That's right. And I can't wait to get into the public company market with an AI-powered system to do press releases, to do like meeting, you know, agreements between everyone. Like we would use this system for board of directors to pass votes and run shareholder meetings and put out press releases in real time, watch the market analysis. Our overheads for all the consultants that we used to have to use would be like, "Oh man, we got this." Like we don't need half that.
One man army, eh?
Yeah, that's it. One man army. Probably be more like three, maybe four, but it'd be very, very small. Very small.
Yeah, yeah, and I mean, sounds fun too.
Yeah, great fun.
Okay,
Okay,
well, I'm gonna jump off, but
thank
thank you
you.
again, and yeah, I mean, it's always a pleasure.
Likewise, likewise. Okay, buddy. I'll speak soon.
Have a good day. Bye.
Bye.